Chapter 20, Electrochemistry. It's my observation that a lot of chemistry instructors don't feel comfortable with electrochemistry, but my master's degree was in analytical chemistry and specifically doing electrochemistry, so I really like this stuff. The quote here is kind of interesting. "One day, sir, you may tax it." Michael Faraday. So this needs some context. Michael Faraday was working with electricity, and Mr. Gladstone, who was in charge of British, finance and stuff, was asking, well, what's the point of this? What's the practical, how is this going to be useful? Because at that point, there was nothing useful about it. And of course, now we understand that electricity is extremely useful, right? And our lives would not be at all the same without it. And the reason I bring this up, the reason the book brings it up, is just to point out the value of research for the sake of research, without a specific practical purpose in mind, but just learning about the universe, right? There's benefit to it. So, this first section we're going to talk about lightning and batteries. So, we've all seen lightning. That's a very dramatic demonstration of how powerful the flow of electrical charge can be. Batteries work on similar principles, but in a more controlled way. The driving force is the same for both of them. Electrons, negatively charged, electrons flow away from negative charge and towards positive charge. And that's the driving force for electricity. So, have you ever wondered how lightning works? So, in a thundercloud, you've got these violent air currents, and they're causing water droplets to collide with ice particles, and that knocks electrons off some of the molecules. So that creates positive charges and negative charges. And the positive charges accumulate on the ice crystals, which tend to go towards the top of the cloud on rising air currents, and the negative charges remain in the wet, slushy part of the bottom of the cloud. And so you get this separation of positive and negative charge, which nature does not like. So that charge separation will exist until it builds up to a point where a channel of ionized air develops, and then all of a sudden this charge imbalance rebalances itself very quickly and rather violently. And you get this lightning flowing. And you can see it. If you've ever seen, you can make, excuse me, you've got two wires connected to a battery or something. If the battery's powerful enough, you can make electricity jump across a small gap. In fact, I have a lighter in my office that we can look at if you want to, that operates on that principle. It's just a gap between two little electrodes, and you put enough voltage on there, and you can get electricity to jump from one side to the other through the air. And that's like miniature lightning. So most lightning happens either within one cloud or between two different clouds. But if the cloud gets close enough to the ground, then the negative charge on the bottom of the cloud causes the ground to develop a positive charge. And then you can get that channel of ionized air from the cloud to the ground, and that's when we have these lightning strikes that hit the earth, right? And you do not want to be near those. Any questions about lightning? Not that I'm an expert, but. Let's talk about batteries. We all use batteries, but probably haven't really thought about how they work, right? They're just these magical things, right? Science. So in a battery, we have two different substances, and those substances have different affinities for electrons. One of them wants electrons more than the other one does. And so if we separate these substances, one will develop a positive charge and one will develop a negative charge. And we'll get this charge separation until a conductive path is connected that allows the electrons to flow from the negative end to the positive end. We generally do this with a metal wire. So connecting these two substances will allow the electrons to flow through the wire, and those electrons can do electrical work as they flow. And there you go. That's electricity. Any questions?